Hey everyone, today we are going to create a Daisy UI component generator using the new structured outputs from the OpenAI API. Let's quickly take a look at this. Here is a component it had generated. Now let's try to generate a more complex card with 6 individual segments with image placeholders. Here is our card. This time it has 6 segments in it, each with individual image, for example. We can also ask for a simple form. Let's generate a simple form. There you go. This is our form. Along with its explanation, we also have dark mode and light mode. We will also look at some simple examples and also an autocoder implementation using structured outputs. We will look at what structured outputs means. Also, we will take a look at specs of the new model as well because it's cheaper. Code files for this project will be available at my Patreon. Link will be in the description. We will demo this app more and talk about the code, but let's begin with what structured outputs is. So as you know, probably with JSON mode, we were able to get exact JSON structure, but the schema adherence was not guaranteed. Here is on OpenAI's internal evals complex JSON schema following, we can see that GPT-4o model was actually getting about 87% of the time, 86.4% of the time, sticking to the exact schema. But with structured outputs, we are able to get 100% exact schema we're looking for. So this is on par with function calling. It achieves 100% reliability. Now, another interesting thing is that this latest model with structured outputs also has 16,000 token outputs instead of the 4,000. So that is pretty nice. Also, the latest model is 50% cheaper for 1 million input tokens. For any amount of input tokens, it's 50% cheaper, and it's 30% cheaper for output tokens. So in a nutshell, structured outputs provide reliable type safety, explicit refusals. Now the refusals are provided within the JSON object, so they're programmatically detectable, and simpler prompting, no need for strongly worded prompts to achieve consistent formatting. Now let's go back to our component generator, and then let's test out the autocoder. Then we'll go over the documentation more in depth and review the code. Like I said, the code files will be available at my Patreon. Link is in the description. Here I have generated a colorful customer feedback card, and this is what it generated along with its explanation. This is all returned with the structured JSON output, which we can then parse and directly display as HTML. We can use this for React components as well. But the application we're going to look into is a FastAPI full stack application. Here is another one, a colorful customer feedback gallery with arrows for navigation. For example, this is a single component. There is a standard website header with drop-down options along with other links. So this works well, obviously can be improved upon. And the next application is the autocoder, which allows you to create Python applications and also iterate over them. Let's run this real quick. For example, before running, this is something I created with iteration. It's actually a calculus course. I was testing the output limits, but I hit a limit anyway. Maybe the API is still early. I got too long API errors for parsing, but this was created in 4 or 5 iterations. So this is how it works. You enter your coding task, or you can prompt it with an auto prompt. Let's first ask for a GPT-4 chat application, and then it'll allow us to iterate. Then we can enter auto prompts. For example, we can say auto to improve this code, then it'll work 2 times more, iterating over the code to apply your instructions. But currently, it's just taking a single shot, a single instruction, working on it with a single pass. Now we can see that it actually tried to return it in JavaScript because we did say a chat app. I guess I can say auto to convert this to Python terminal app and improve it. So it starts the first iteration. So hopefully it should convert this JavaScript app into a Python app, and in the also had some improvements for 2 iterations. Here is the first. It actually turned it into a Flask app, as you can see. And next, it's going to improve it. Here we go. We got the improved version, which is longer. So this is how the autocoder works. Let's take a look at quick examples. So when we are using the new structured outputs, we do need to define a complex schema, such as we do with function calling. But when I introduced the Pydantic SDK, and it allows you to define your schemas using Pydantic, and that is the recommended method anyway. And when you do that, you can just pass your final Pydantic object in as a response format, and then you're all set to go as long as you've set your model to the correct thing. Here in this case, we are asking GPT to become a helpful math teacher, guide the user through solutions step by step. For example, how can I solve this? The steps are going to include a list of steps, which is going to consist of explanation and output, and then the math reasoning will return a final answer. So when we run this, let me break out of this and run it. So this should return to us the entire response here in a moment. We do have to print it, so let's run it again. There you go. These are the steps. We can actually parse through them and print them separately as well. For example, we can just print the final answer by asking dot final answer. Here is the final answer. We can also print for each steps plus the final answer. Let's run this again. There you go. These are the steps, and the final answer is printed at the end as well. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the FastAPI course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Let's go over the documentation real quick. Structured output is a feature that guarantees the model will always generate responses that adhere to your supplied JSON schema. In addition to supporting JSON schemas, the OpenAI SDK for Python and JavaScript make it easy to define object schemas using Pydantic or ZOD for JavaScript. So essentially, you just define your schema as a Pydantic object. For example, this calendar event is going to return a name, date, and participants. You can define their types. Participants is going to be a list. And then all you have to do is set the response format to the calendar event. I do still believe you still have to mention the JSON object. The JSON word in the message. You'll get an error that telling you to do it anyway. But this is as easy as that. Here are some examples. For example, chain of thought examples where you're asking the model, just as we did during math reasoning, to include some steps. You can define how each step is going to look like. You can also perform structured data extraction, for example, research paper extraction with title, authors as a list, abstract as a string, and keywords. Again, all you're doing is just passing in the model, and you don't even have to pass any user message here in this case, as long as you've given it a good system message. Another example is UI generation, which we have used. So take a look at this as well. We've done it a little bit differently, but you can do it like this as well. Moderation. You can classify inputs or multiple categories, for example. Here, in this case, we're checking for these categories and content compliance object we pass. The category is being passed as the category right here. So this is very useful, especially since it will adhere to 100% to the schema you described. Structured outputs versus JSON mode. So they will both output exactly valid JSON objects, but JSON mode will not adhere exactly to the schema. It will adhere to it, as we've seen, about 87% of the time. Compatible models are GPT-4o Mini and the latest GPT-4o model. JSON mode is compatible with all modern models, enabling. So there's a different way of enabling it. If you're not using Pydantic objects, you do have to specify response format just as you would with JSON mode. But you also specify JSON schema strict true along with passing in the schema. and it can be used in function calling if you've set the strict to true in the function definition. So structured outputs available both in when function calling and when using a JSON schema response format. So the first step is to define your object. This is for SDK objects. You can also define a manual schema. We'll take a look at both, but so you define your object such as this, that's applied as the math response. And you can also handle edge cases. By the way, this is how you set strict true within the response format schema. This is if you're providing a regular JSON schema and not using the Pydantic objects, you set strict to true. And you put this in a try and except block and handle the exceptions such as refusals, content filter, and a finish reason. And now you can use output in a type-safe way by using solution.parseRaw or in our example by using completion.choices.messages.parsed. And when we are calling it, the difference is also, as you can see, we are using the client.beta.chat.completions.parse when we are using it as a Pydantic when we are passing in the Pydantic object. So this dot parse along with the beta, and when we are actually extracting the JSON object, completion.choices message.parsed. Okay, just remember that. As long as you do that, you will be good to go. Now, when you're providing a manual schema, you do set the response format to type JSON and JSON schema, your schema plus the strict true. Here, this is how we're doing it. Response format, type is JSON schema, and then you input your JSON schema. And at the end, you say strict true to be able to use the structured outputs. When you do it like this and not with Pydantic objects, then you can actually retrieve your response regularly. And you can actually call the regular endpoint as well. So this beta and the parse is required when you're using Pydantic objects, but that make your life so much easier. Plus, it is actually recommended by OpenAI. So if the model refuses, it returns a refusal field, so you can actually detect this. Check if this refusal exists in your messages, and you can know why the refusal has happened, for example. So yeah, just read over. This is in the documentation on OpenAI. Just click on structured outputs. There's also much more information about supported types and how to get that key ordering, for example, or to be able to use any of for nested schemas. So there's quite a lot of information which we're not going to get into. Yeah, so this is very useful. Like I said, everything you see in this project will be available at my Patreon. I actually modified my unified.py file, which we are using to build these projects to include JSON response. Unified APIs actually makes it easy for you to build LLM-powered applications. By default, you can use GPT-4o, Cloud 3.5 Sonnet, or even Gemini Pro 1.5 from OpenRouter. If you want to know more about this, you can find at my website, the Unified API. My website is echohive.live, where you can actually find all my videos there as well. And if you're a patron, you'll be able to download code files. Also have access to my 1000x masterclass, with which I teach how I code fast using Cursor IDE. But if you take a look at this, you do see that the get response method I have modified to check if it's because the structured output is only available through OpenAI. We check first if the provider is OpenAI and check if the response model is present. If the response model is present, which we will pass as a keyword argument to the chat method, which then passes it to get response. Then we call the client.beta.parse. We pass in the response model, whichever was passed. And also, when we are parsing it, if response model and the provider is OpenAI, then we use the argument to actually get the assistant response. So we have looked at the simple example, right? We are using Pydantic space model, define our object, the schema, and then just pass it in as it's a response format and use the .parse to get the response. While making the call, use beta and parse endpoints as well. So the autocoder works similarly, but we have a very simple schema, code response, which is going to include a plan and final code. We are going to print some useful information for the user that they can immediately enter a coding task or enter an auto prompt, such as example right here, how many iterations and a prompt to execute automatically. Generate code. We are using unified API, so we import that. It's going to take an unified client, user input, and previous code. If there is any system messages, you are both a software architect and an expert programmer. First, create a plan to implement given coding task, then follow the plan to generate code step by step. Right after this, we'll take a look at the FastAPI app as well. Now we set the system message as the system message. If there is previous code, we pass that in along with the user input. Generate the code response. As you can see, we're just calling the chat method of the unified class and then passing in the response model, which we have created. Then we print it and display the final, and we print the final code because here we're printing the plan. We save it to a Python file. If there is this present in the object, then we remove it because it often is. This returns it in the main function. We initialize our unified APIs as OpenAI and the latest model. Previous code is initially none. We get the user input. And if the user input starts with auto, we parse it as in iterations and initial prompt. Then we print an information statement saying starting auto generation for this many iterations with this prompt. And for in range of these generations, we just generate the code. That's it. And otherwise, if it's not auto generation, then we generate it one time. Now with the so this is the if you look at the files, it's the autocoder.py file. Example.py includes a basic example. Response.py is whatever is written as the result of autocoder.py. Here are the requirements. You do have to update your OpenAI library. I should have mentioned this in the beginning, but make sure you install OpenAI dash dash upgrade. And here is the unified.py we are using to build these apps, and there's a README for it as well. But the main.py is the FastAPI app, and under templates, we have the index.html, which is very simple. Let's begin with the index.html because we are using Jinja templates. So therefore, we are actually not even using much JavaScript. We are only using JavaScript for light and dark mode toggling. As you can see, we are using Jinja templates to actually render the components. If there is components, then whatever the components is, we render the HTML for that along with the explanation and then end it. So this is very simple. Consider using it in other use cases as well. Other than that, it's just styling, and we are using Daisy UI and Tailwind. Daisy UI is a components library over Tailwind. If you look at the main.py, it is a fast API app. We are importing unified APIs, initializing Jinja 2 templates from the templates folder. We do create the identic schema for JSON structured response. HTML component is going to be returned as HTML in explanation, and the AR response is going to be a list of components. So you can make this so much better. Actually, remember that. We initialize our unified APIs and define our first main page route for FastAPI, which is just going to return a template response of index.html. And we have a generate endpoint, which is going to take in a request and a user input. You are an AI assistant that generates HTML components using Daisy UI classes. So here's the instruction. And we set the system message of unified client, and then we simply call the chat with the user input. When the response returns, we simply override the template index.html with the request components and the user input. And this part is how we can run our app. But we can run it from the terminal by saying unicorn main dash dash app, colon app dash dash reload. Unicorn is to start the server. Main is the name of the file, main.py. App is the fast API app we define, and this dash dash reload allows this server to restart and reflect the changes in the web page if anything has changed in the Python file. I hope you enjoyed this video. If you like to find other videos, please do visit my website, acquire.live, and consider becoming a patron, where I have 250 projects for my patrons. But the most important one, in my opinion, is the 1000x Dev Masterclass. I have 14 parts to this, in which I build projects from scratch. Each zip file includes a video plus the full project files for the applications. I update this regularly. Last time I updated was on the 5th of August. So this is an ever-growing course. Also, I have a special event scheduled for August 10th, 12 p.m. 2-hour live session with Cursor live coding for Connoisseur Plus patrons. So if you do become a patron now, you'll be able to attend this event. I also have Ask Me Anything meetings every week with my Architect Plus patrons. If you wanted to talk to me, watch me code, or talk to other patrons, like-minded individuals, if you don't forget these. Yeah, last one was on Sunday the 4th, and the next one should be on Sunday the 11th. I also have tiers on my Patreon for consulting. If you want to talk to me one-on-one, check those out as well.